All right, I've already started working on my journal here because my computer shut down in the middle, so we're gonna do our best to have you not see the answers. We're gonna look at multiplication and division of inequalities today, and you need to know the properties of inequalities as it goes for division and multiplication. So you can multiply both sides of an inequality by the same positive number, and the inequality remains true. Also, you can divide both sides of an inequality by the same positive number, and the inequality remains true. So these are two separate properties. One is for multiplication and one is for division. So let's look at my example here. I have 2x is less than 12. Well, the property of division says I can divide both sides by the same number, and this is just how we're going to look at for solving these. And to solve that, I would divide both of those by 2. Then I have 1x, bring down my x, is less than 12 divided by 2 is 6. So then I graph this, and I'm going to have an open circle at 6 because there's no equals. And then my arrow is pointing to the left, all the values less than. To check it, I'm going to take my original inequality, input one of these values here, and I chose 2. 2 times 2 is less than 12. 2 times 2 is 4. 4 is less than 12. That is true. Okay. I took the same inequality here that I solved, and then I'm going to multiply over here. So I took this x is less than 6, and I multiplied both sides by 3. Now I have 3x is less than 18. And then I am going to take one of my values here, and I chose 5. 3 times 5 is 15, which is less than 18, and that's true. So we've just proved that we can divide the same number on both sides or multiply the same number on both sides, and my inequality is still going to be true. All right, so my next example is y divided by 3 is greater than 5, or greater than or equal to 5. And then to solve it, inverse operations, when I have division, we're going to multiply. So multiply by 3, multiply by 3. And that, what it looks like is 3y divided by 3, and then 3 divided by 3 is 1. We bring down the y. So what you're going to see me do is I'm just going to show you this part. We need to know that the number divided by itself is going to be 1. Then 5 times 3 is 15. And my inequality is now y is greater than or equal to 15. So I've graphed it, greater than or equal to, so I have a closed circle, inequality heading to the right, same as my arrow in my inequality, right? And then I have to check this. So I chose one of these numbers, and I chose 18, and I plugged it in for my y. 18 divided by 3 is greater than or equal to 5. 18 divided by 3 is 6. 6 is greater than or equal to 5. That's true. All right, so now I'm going to try and show you the your turn, and we're going to look right here. So 5x is greater than or equal to 100. And let's move this up here so you can see it. 5x is greater than or equal to 100. I want you to solve that. And then the next one I want you to solve, I can't show it to you right now. I'll just show it to you. It's going to be z divided by 4 is less than 11. Z divided by 4 is less than 11. Go ahead and solve those. All right, so I've already worked this out here. Number 3, I had 5x, so I need to divide by 5, divide by 5. 5 divided by 5 is 1. We bring down our x. 100 divided by 5 is 20. And now I have x is greater than or equal to 20. I've graphed my solution. Closed circle at 20. Arrows heading right, same direction as my inequality symbol. And then I checked it right here. I took my original inequality, 5x greater than or equal to 100, and I input one of my values from my graph, which I chose 21. 5 times 21 is 105, is greater than or equal to 100. That's true, so that does work out. All right, number 4, z divided by 4 is less than 11. Remember, the inverse of division is multiplication, so we need to multiply by 4 on both sides. 4 divided by 4 is 1. I'm left with z. Less than 11 times 4 is 44. All right, I need to graph this now. All right, open circle at 44. I'm gonna use a different color. And my arrow is all these values less than. It's gonna go this direction. And we're gonna check it. So let's choose 40 would be right here. We're gonna choose 40 because I want a nice number here. Input 40 for Z. 40 divided by 4 is less than 11. Well, 40 divided by 4 is 10, and 10 is less than 11, so that is true. All right. Next, I want to show you with a model. Write the inequality shown on the model, then solve. So I want you to go ahead and give this a shot. All right. So we need to know that these rectangles are representing x. So if you didn't know that, that would be hard to solve this and set it up. So right here I have 2x, and then my inequality is less than. And right here, these are just one counters. So 1, 2, 3, 4, 5, 6, 7, 8. So 2x is less than 8. So this is my inequality represented by the model. And then if I were to solve that, I've got 2x. I need to divide by 2, divide by 2. X is less than 4. And we could graph that if we wanted to. 4, 5, 6, 3, 2, 1. Open circle at 4, and all the values less than. All right. I want you to solve each of these, number 1 and number 2 here. I've got 8y is less than 320. And then number 2, r divided by 3 is greater than or equal to 11. Go ahead and solve those. All right, so for number 1, it's multiplication, so we need to divide by 8. Divide by 8, 1. I bring down my y is less than. 32 divided by 8, you will get 40. And let's graph that. So 40, 38, 36, 42. Open circle because there's no equals, and my arrow is headed to the left or less than values. All right, for number 2, r divided by 3, so we need to multiply by 3 on both sides. 3 divided by 3 is 1. We bring down r greater than or equal to. 11 times 33 is 33. And then let's graph that. And let's put 33 right here, 35, 37, 31. All right. So I'm going to have a closed circle at 33. Let me change colors again because it does include the equals. And then I'm going to all the values greater than, like that. Hopefully you did really well on this. I know I went kind of fast. These follow the same steps as equations though. So far we should be doing good. It's just knowing when we have an open or closed circle when it goes to graphing them. If you have questions, please come and see me during my meeting or send me an email. Have a great day.